Okay, so now we're going to look at how we can work out how long a wave is. That's basically asking for the wavelength. Now the first thing we have to do is work out how many waves there are. So 1, 2 waves. Now those 2 waves are 10 centimeters long in total. So the 10 centimeters has to be split or divided between those 2 waves, which gives each wave a wavelength of 5 centimeters. Let's try this one. How many waves are there? Pause the video if you need time to think. Right, we're going from trough to trough. So we've got 1, 2, 3 waves. And those 3 waves measure a total of 60 meters, And the wavelength is going to be those 60 meters shared by those 3 waves. 60 shared by 3 waves means that each wave has a wavelength of 20 meters. In this example, sorry about the wee scribble, we have 20 meters shared by how many waves? Pause the video if you need to find out. 1, 2, 3, 4. So we've got 4 waves sharing 20 meters. So the wavelength is that 20 meters being shared by the 4 waves gives us 5 meters for each wavelength. Now, sometimes a question won't give you the full length of the waves. It will only tell you a portion, and that is what you're counting from and to. So here we've got 1, 2, 3 waves, and you can ignore the rest. 3 waves are 12 centimeters in length. So that means the wavelength of 1 wave is at 12 centimeters divided by 3, because the 12 centimeters is shared by the 3 waves, and that gives us 4 centimeters. Now, sometimes questions are slightly different from that. And instead of asking you for the wavelength, it gives you the wavelength. So here the wavelength is 5 centimeters. What is the total distance from X to Y? Well, now we need to know the number of waves. So can you count them? One, 2, 3, 4, 5. We have 5 waves. Each wave has a wavelength of 5 centimeters. So we have 5 waves, and each wave has 5 centimeters, which means we have a total of 25 centimeters between X and Y. Sometimes wave diagrams can be drawn like this. It's as if a pebble has been dropped in a pond, and each of these lines represents the crest or the top of one wave, as if you were looking down from above, and you just see the crest of each wave, and in between you will have the trough coming down up to the crest, down to the trough, but we only draw the crest in the diagram. So we need to find the distance from where the stone was dropped in to here, the 3rd wave crest. 1, 2, 3. We know the wavelength is 2, so we have a wavelength of 2, and we have 3 waves. So we have a distance of 6 centimeters. Okay then, bye.